For decades, telescopes around the world have been scanning the sky for faint traces of moving objects. But nothing prepared astronomers for the moment when the first truly interstellar visitors appeared. The detection of Oumuamua, Borisov, and later 3 IATLAS forced observatories to rethink their methods, upgrade their instruments, and, as some quietly admit, review what data should be shown to the public and what should remain unseen. The fact is simple. Modern telescopes can detect extremely faint objects by stacking images and tracking tiny motions across the sky. The interpretation is clear. This method works well for asteroids and comets formed within our solar system. But some researchers note that the detection of Oumuamua happened under surprisingly ideal conditions. The telescope was pointed exactly where it needed to be, at exactly the right moment. In the online community, there is a circulating suggestion that this luck might not be accidental at all. Some believe that an automated alert system may have flagged an unusual trajectory hours earlier, but these logs have never been published. Why those internal notifications remain hidden, no one officially comments. When 2I Borisov was discovered, the same pattern appeared again. The fact: the comet was detected during routine sky surveys. The interpretation: it behaved like a typical comet, though from another star system. Yet several astronomers admitted anonymously that the object was visible on earlier images that were later removed from open archives. Whether this was a technical cleanup or a deliberate restriction is unclear. At the same time, satellites showed a brief electromagnetic disturbance over the region where one observatory was located. Whether this is related remains unknown. Then came 3 IATLAS. Telescopes caught it only after an unusual spike in brightness that lasted less than an hour. The fact: such brightness spikes happen with volatile comets. The interpretation: Atlas simply released a burst of gas or dust. But some researchers say the spike timing was too precise, almost as if the object announced itself. In the same time window, radar data from a nearby tracking station went offline for reasons that were never explained. According to several specialists, access to certain spectroscopic files was restricted minutes after upload. The official statement: routine maintenance. Unofficially, some staff admitted that the data showed something they had never seen before. One more detail adds to the mystery. On satellite imagery from that night, a dark rectangular zone appeared exactly over the observing region. It was quickly replaced with an updated photo. Whether this was a glitch or intentional editing remains uncertain. But the timing raises questions. All these episodes lead to a broader concern shared quietly among scientists. What if our telescopes are seeing more than the public is told? What if some signals, shapes, or trajectories appear too unusual? So unusual that they are flagged, filtered, or temporarily removed. Whether all this is coincidence or indicates something more complex is for viewers to decide. Many versions exist, and none has been disproven yet. Everything might be simple or far more complicated. Every telescope on Earth collects far more data than astronomers can publicly analyze, and this simple fact often becomes the foundation for speculation. Modern sky surveys generate terabytes of images every night, filled with faint streaks, unresolved flashes, and signals that never make it into research papers. The official explanation is that most of these anomalies are noise, camera artifacts, or satellite reflections. Yet some observers claim there is more to the story than dismissed pixels and sensor glitches. One confirmed fact is that survey software automatically filters anything that looks inconsistent with known celestial objects. Fast-moving tracks, irregular brightness spikes, or sudden trajectory shifts are often flagged as false detections. The interpretation is practical. Removing these artifacts saves time. But several engineers who worked with such systems have stated anonymously that the algorithms sometimes reject objects that later turn out to be real. According to them, certain detections were too perfect or too linear to be random noise, yet they vanished from the logs after automated cleanup. Why some internal records disappear while others remain is not publicly explained. There's also a recurring rumor that some observatories maintain a category called unclassified transient objects. These do not appear in public databases, and their coordinates are shared only within closed mailing lists. The official line is simple. These are usually incomplete detections that require verification. But in recent years, the number of unclassified reports allegedly increased, especially after the appearance of interstellar bodies. Detractors argue this is natural as instruments become more sensitive. Others, however, whisper that telescopes may be seeing something that does not fit existing catalogs or existing expectations. A notable incident occurred during a sky scan over the southern hemisphere. The fact, a telescope detected a sharp, narrow light curve inconsistent with typical comets or asteroids. The interpretation, the spike could have been a micrometeorite hitting the telescope sensor. But according to a technician who later spoke anonymously online, the object moved in a way that looked intentional. Within an hour, the corresponding raw data were removed from the open archive, replaced with a generic placeholder file. No official statement followed. Another curious event involved several observatories across different continents that reported the same faint object appearing and disappearing within seconds. The fact is that synchronization between observatories occasionally produces false coincidences. Yet in this case, the timestamps aligned perfectly. In the same time frame, unusual electromagnetic fluctuations were detected in the ionosphere above one of the stations. Researchers insisted the two events were unrelated. Some data analysts disagree, implying that a connection is not impossible and might warrant investigation that never happened. Satellite imagery adds even more uncertainty. Several sky watchers noticed that certain regions near key observatories occasionally appear blurred or patched over in publicly available images. Agencies attribute this to standard privacy protocols. But skeptics argue the timing of the edits often aligns with nights when unexplained optical events were reported. Whether this correlation is meaningful or simply accidental remains open to interpretation. All these cases create an uncomfortable but persistent question. Are telescopes filtering noise or filtering the unexplainable? Are missing files and restricted datasets just routine housekeeping, or signs of something quietly happening behind observatory doors? Most sky events unfold slowly. A comet brightens over weeks, an asteroid's motion shifts over days, and telescopes generally have time to plan observations. Yet, according to several observers, there have been rare moments when the reaction from certain observatories seemed far too quick, almost as if they were waiting for something. This unusual speed has become a subtle but persistent point of discussion among astronomers who prefer to remain unnamed. A verified event occurred in early 2020 when a wide-field survey telescope captured an object with an unusually sharp acceleration curve. The official interpretation was that the system miscalculated the position due to a transient atmospheric distortion. However, some data analysts pointed out that the follow-up observations were initiated in under 3 minutes. For comparison, most anomalies take at least 30 minutes to confirm. Why this detection triggered an immediate response remains unclear. There is also a recurring claim that some observatories possess internal alert systems not disclosed to the public. These are said to activate only for objects moving at speeds inconsistent with typical solar system dynamics. The existence of such alerts has never been confirmed, Yet several former graduate students mentioned hearing unusual alarm tones during overnight shifts. When they asked about the purpose, they were allegedly told not to worry, just a calibration check. Whether that explanation was truthful is impossible to verify. Another strange incident involved a mid-sized facility that unexpectedly shut down its main dome for several hours after capturing a bright, needle-like flash across the sky. The fact, the dome was indeed closed, and the official statement blamed incoming bad weather. Yet weather reports from that night show clear skies. Meanwhile, in a local forum, an anonymous user claiming to be a technician wrote that the staff were instructed to leave the building temporarily because of instrument interference. He added that the real cause looked more like an incoming signal than a fault. The message disappeared within a day. Different observatories occasionally report synchronized downtime, usually caused by scheduled maintenance. But there was one particular case where 3 stations, thousands of kilometers apart, went offline within the same hour. The interpretation provided was a widespread network outage. Some cybersecurity specialists dispute this, noting that each observatory uses an independent communication channel. According to them, a simultaneous failure is theoretically possible but statistically unlikely. In the same time frame, several amateur astronomers reported a bright moving object that changed direction abruptly, something no known natural body should do. Whether the downtime and the sighting were related remains a topic of debate. Several employees from a large solar observation facility, speaking quietly through encrypted channels, suggested that the real reason some observatories react so fast is that they have access to early warning data fed from classified satellites. These satellites reportedly detect high-velocity objects entering the inner solar system. While this idea cannot be proven, it would explain why certain telescopes seem prepared before the public even knows something unusual is happening. And then there are the missing logs. A handful of observation nights show incomplete entries, with timestamps jumping by several minutes. The official explanation is that software updates cause the gaps. Yet some astrophysicists speculate that these windows might correspond to moments when telescopes saw something that wasn't meant to stay in the record. Whether these quick reactions are simply coincidences, technical glitches, or signs of something astronomers aren't allowed to discuss remains uncertain. The pieces do not form a clear picture, but they form enough of one to make people wonder. Astronomy is a science built on precision. When a telescope records brightness, trajectory, or spectrum, each value must align with the models that have been refined for decades. Yet there are moments when the data simply refuses to behave. Most of these anomalies are minor and dismissed as equipment noise, but some leave traces that are harder to explain and harder still to ignore. One documented example involved a long-exposure image taken by a high-altitude observatory. The fact is simple. The image showed a faint, elongated streak, thinner than typical meteors, and moving at a strangely consistent velocity. The official interpretation was that the streak came from a passing satellite. However, satellite tracking databases show no object in that orbit at that exact moment. When several independent hobbyists attempted to reanalyze the raw frames, they discovered that a portion of the metadata had been overwritten. According to them, the missing entries were not random. Why they vanished, no one has said. In another case, a cluster of observatories recorded a brief but clear electromagnetic spike. It lasted less than half a second, too short for natural sources like solar flares. A few researchers proposed that it could be a distant pulsar emitting an unusually sharp burst. Yet telescopes pointed in the same direction later detected nothing similar. Some online commentators suggested that the spike resembled a communication ping rather than a cosmic event. No official statement addressed this interpretation. There is also the matter of the spectral lines. A routine scan of a fast-moving object revealed chemical signatures inconsistent with typical cometary material. The fact, the lines were real. The interpretation. Perhaps the object contained exotic ices or underwent unusual heating. But several astronomers quietly noted that the lines resembled emissions produced by certain engineered alloys when exposed to high radiation. Whether the object truly contained such materials is still unknown, because the original data set was flagged under revision and then never republished. Another puzzling moment occurred when an automated telescope failed to track an object that it had locked onto only minutes earlier. The system claimed the object changed direction by nearly 40 degrees, an impossible maneuver for natural debris at such distance. Instead of publicly discussing the anomaly, the observatory released a brief message saying the drive motors had temporarily desynchronized. Yet a technician later hinted online that the motors were functioning perfectly and that something else must have caused the sudden shift. A subtle pattern also appears in satellite images, occasional dark zones, patches where pixels look blurred or replaced. Most are likely processing errors. But in at least one case, the blurred region aligned with the predicted path of a fast incoming object. The updated images uploaded hours later contained no blur at all, as if the anomaly had been edited out. Some researchers argued this might be a routine correction. Others wondered why corrections appear only on nights with unusual detections. Several analysts mention whispered conversations about invisible frames, missing slices in time where the recording equipment jumps ahead as if skipping. These skips usually last fractions of a second, too short for the public to notice. Yet if something bright and fast crossed the sensor during that moment, it would leave no trace. Whether these skips are technical faults or intentional filtering remains debated. The strange part is not that anomalies exist. Every science encounters them. The strange part is how often they disappear before anyone can study them. Whether this points to overcautious data cleaning or something far more deliberate is a question no official source is prepared to answer. The gaps remain silent and unexplained, waiting for someone brave enough to connect them. Modern astronomy looks open and collaborative on the surface. Telescopes sharing data, scientists publishing results, universities comparing findings. But behind the public face of discovery exists a quieter, far less transparent layer, a network of observatories, radar stations, and classified sensors that monitor the sky with a level of precision most people never hear about. Some of these systems were built to track satellites, others to watch for incoming asteroids, and a few, according to certain insiders, to detect anything that doesn't fit into known categories at all. The confirmed fact is this: nearly every major country maintains some form of sky surveillance infrastructure. Radar arrays sweep the upper atmosphere, infrared detectors watch for heat signatures, and high-resolution optical telescopes capture objects only a few meters wide. The interpretation is that these systems exist for safety and defense. Yet in several documented cases, parts of their recordings were withheld or redacted when unusual objects appeared. One example came from a coastal radar facility that detected a fast-approaching body entering Earth's neighborhood at a sharp angle. The radar logged the object for approximately 6 seconds before the data feed abruptly ended. The official reason was a temporary systems outage. However, a leaked internal report mentioned that technicians attempted to retrieve the raw logs, only to find the directory emptied minutes after the shutdown. Why the files vanished so quickly, no one has offered a detailed answer. At the same time, a mountain-based optical telescope reported a bright flash moving across 3 consecutive frames. That telescope's automated system flagged the event as unclassified. Soon after, access to the full resolution frames was locked. A junior staff member, speaking anonymously, claimed that he saw a shape in the raw images, something slightly angular, not fully symmetric, unlike most natural space debris. He also said he was told not to mention it again. Another pattern appears in the timing. Several telescopes around the world, including civilian ones, have reported brief downtimes that coincided with moments when unexpected objects passed through their scanning zones. In one case, an observatory's tracking system rebooted precisely 38 seconds before a high-velocity object crossed Earth's orbital plane. The reboot log showed manual override, though the staff insisted they had not touched the controls. A few researchers have pointed out something else. Some space surveillance networks occasionally operate in what insiders call quiet mode. During these intervals, live data streams cease, updates stop, and the public receives no new information for hours or even days. Officials say these are maintenance periods. Yet the timing of several quiet modes aligns unusually well with known passages of fast, non-catalogued objects entering or leaving the solar system. There is also an intriguing claim involving orbiting infrared sensors. According to a former contractor, these sensors detected a cold, dim object moving with near constant speed, too cold to be a typical comet, too dim to be a fragment reflecting sunlight. Shortly after the detection, the entire sequence was classified. Whether the object was something artificial or simply an anomaly in the detector is still a matter of speculation. And then there are the whispers about a shadow archive, a closed system where certain astronomical observations are stored, analyzed, and then selectively released to the public. Only a handful of people reportedly have access to it. If such an archive exists, it may contain records of objects whose characteristics do not match natural origins at all. No official agency acknowledges these discrepancies, and perhaps they never will. But the scattered clues, missing data, synchronized outages, locked images, suggest that the sky is being watched far more closely and far more quietly than most of us imagine. Whether this secrecy protects us or hides something else entirely remains an open question. When astronomers search for interstellar objects, they rely not only on visible light, but on a whole spectrum of signals the human eye can't perceive. Infrared emissions, ultraviolet flashes, reflected radio waves. Each offers a clue about an object's shape, speed, temperature, and sometimes even its chemical makeup. The factual part is simple. Telescopes across Earth and in orbit are equipped to observe these signatures. But in several notable cases, they have recorded signals that don't align with any known natural process. One confirmed example is the phenomenon of irregular spectral breaks. Normally, when a comet reflects sunlight, its spectrum shows predictable dips corresponding to common molecules like water or carbon dioxide. Yet during one unusual observation run, a deep space infrared detector captured a signature with a perfectly straight cutoff, as if some material was absorbing light at specific wavelengths with almost engineered precision. Scientists publicly called it a processing artifact, but internal notes from the same research team reportedly questioned whether a natural object could produce such a clean edge. According to one astronomer who spoke anonymously, the detector triggered a high-priority alert, something that usually happens only when satellites or classified hardware pass through the field of view. Why an alleged interstellar object produced the same reaction is unclear. The alert logs were later removed from the server for storage optimization, though several staff members insist that older, less significant logs were left untouched. Another case involves polarization readings. Polarization is the orientation of light waves, and in nature it tends to be random or influenced by dust and ice. But telescopes in Chile, Spain, and Hawaii very briefly recorded a synchronized polarization spike from a fast-moving point in the sky. The spike lasted roughly 0.7 seconds, barely long enough for the automated systems to react. Some researchers believe the synchronization across continents may have been coincidence. Still, Others argue that for three independent instruments to log nearly identical readings is statistically improbable unless they were detecting a structured, possibly metallic surface. During that same window, radio telescopes registered a faint but highly ordered pattern, not strong enough to be called a signal, yet too geometric to be noise. The official stance was that it came from an Earth-based interference source. Curiously, the interference file was flagged as internal, even though no local equipment was active at the time. Several amateur astronomers also reported seeing a brief shimmer in the same patch of sky, describing it as similar to sunlight glinting off a smooth surface. Their reports were dismissed as observational errors, but a few of them later claimed that images uploaded to online databases were quietly removed without explanation. Whether this was routine maintenance or something else is impossible to confirm. A more puzzling incident occurred at an infrared station in the Arctic. The detector captured what appeared to be a cold object with a warm outline, the reverse of what natural bodies typically show. The warm outline shifted slightly between frames, almost like controlled maneuvering. The anomalous frames were replaced within an hour, and when questioned, the station spokesperson insisted the images had been corrupted by thermal drift. However, one technician privately stated that thermal drift usually causes blurring, not precise, shape-consistent patterns. There's growing speculation that some objects entering the solar system emit signatures designed to avoid detection. A few theorists even propose that these signatures may be adaptive, altering themselves depending on the sensor type scanning them. Although this idea is far from proven, it could explain why different telescopes sometimes report conflicting data for the same object. No agency has offered a direct explanation for these anomalies. Maybe they are simply artifacts, software glitches, or misunderstood natural processes. Or perhaps they hint at something engineered, something designed to appear invisible, yet not quite invisible enough. Whether these invisible signatures are warnings, messages, or just cosmic coincidences remains uncertain. As always, the truth might be far simpler, or far more unsettling. The search for interstellar objects is usually portrayed as a purely scientific pursuit, open, collaborative, and transparent. In reality, astronomy sometimes operates behind closed doors, especially when observations raise uncomfortable questions. The fact is that research teams occasionally restrict access to raw data. They claim this is to prevent misinterpretation, which is partially true. But there are moments when the silence surrounding certain discoveries feels heavier than usual. One well-documented case occurred when a ground-based telescope recorded a series of unusually bright flashes in the path of a fast-moving object. The official explanation was straightforward. These were cosmic rays hitting the sensor. Yet several members of the team later admitted that the flashes formed a pattern, evenly spaced intervals lasting exactly the same fraction of a second. Nature rarely works in perfect intervals. When pressed, senior scientists advised the group not to jump to conclusions and sealed the raw files for recalibration. Another example involves time-stamped observation logs. Most research facilities publish these logs openly, but a particular set of entries from a major observatory disappeared overnight. The entries corresponded to the hours during which an unknown object crossed the sky at extraordinary speed. Technicians claimed they were told the logs contained incomplete calibration fields, but one staff member confided that the data had shown a sudden change in the object's reflectivity, something not typical for natural bodies. Why such information would need to be erased rather than corrected remains unexplained. There are also whispers about non-disclosure meetings. According to several researchers who spoke off the record, certain international agencies sometimes request private briefings when anomalous readings appear. These are not formal investigations, but more like quiet check-ins during which scientists are asked to describe the anomaly without releasing anything publicly until context is established. What exactly constitutes context is seldom defined. A more unsettling detail surfaced when a junior astronomer reported hearing a conversation between two senior colleagues. They allegedly discussed an object that responded to spectral scanning by altering its surface temperature within minutes. No documentation of such an event exists, and the astronomer later claimed they might have misheard. Still, the claim lingered on internal forums before the entire thread was removed. Anonymous sources have also mentioned that certain telescope arrays regularly detect brief shadows moving in front of deep space objects, shadows that don't correspond to any known satellites or debris. These shadows appear only for a few frames and vanish before automated systems can classify them. Officially, these are dismissed as noise. Unofficially, some researchers believe they might represent smaller bodies accompanying larger interstellar travelers, almost like escorts. Even more peculiar are the reports of restricted access zones on internal servers. Researchers sometimes discover that specific data folders have been locked shortly after an anomaly is detected. The reason given is always the same: maintenance. Yet, the timing seldom feels accidental. A few astronomers claim that whenever an object exhibits behavior considered unusual, the related files are quickly isolated and later released in trim form, missing certain sections. There are also rumors of instruments automatically shutting down during periods of overload, despite the fact that no overload conditions were recorded. One engineer suggested that the shutdowns might have been triggered externally, perhaps by interference or by something deliberately obscuring the telescope's field of view. The idea sounds far-fetched, yet no official explanation has addressed why multiple systems across different observatories experienced similar failures within days of each other. Some insist these patterns are coincidences, the natural result of human caution and imperfect technology. Others believe that scientists know far more than they can admit publicly. Whether the silences come from institutional caution, classified interests, or something far stranger is still open to interpretation. For now, the unanswered questions remain scattered across locked servers, missing logs, and quiet conversations, waiting for someone willing to follow them to the end. Telescopes are often described as windows to the universe, precise, predictable, and unbiased. But what they reveal when pointed at the right place and at the right moment can be far more complex than the public realizes. The fact is straightforward: modern telescopes capture more data than any human could review manually. Much of it is processed automatically, flagged, categorized, or discarded by algorithms designed to filter out irrelevant anomalies. Yet these same automated systems sometimes capture details that slip through the cracks long enough for a few attentive observers to notice. One confirmed incident occurred when an automated sky survey recorded an object emitting two bursts of light at intervals too regular to be natural. The raw logs clearly showed the flashes. The official interpretation claimed they were reflections from rotating debris. But debris does not typically emit such uniform pulses. Later, when independent researchers attempted to reanalyze the dataset, they discovered that the timestamp metadata for the critical frames was altered, shifted back by several seconds. A system glitch, according to the administrators. Still, several engineers quietly questioned how a glitch could affect only the frames that contained the anomaly. There is also the matter of multi-wavelength imaging. A coordinated telescope network captured an object in infrared, radio, and ultraviolet simultaneously, a rare alignment. The fact, each telescope registered the object at consistent coordinates. The interpretation: this suggested a large, cold body with intermittent surface heating. But the ultraviolet images displayed something not present in the others: a faint, geometric halo around the object. Publicly, the halo was attributed to lens flare. Privately, one researcher mentioned that the halo's shape was too symmetrical to be accidental, resembling a hexagon or something close to it. Another puzzling moment came from a deep space observatory that reported an object momentarily increasing in brightness by more than 60%. Natural explanations include outgassing or fragmentation, but simulations produced unstable results. None matched the sudden spike. Before researchers could publish their findings, the observatory issued a statement saying the sensor was suffering from thermal interference. Curiously, the replacement sensor installed later showed no signs of malfunction. Several amateur astronomers also noticed missing sky frames on public databases. These frames corresponded exactly to the minutes during which an object was expected to pass through a high visibility region. Some suggested the files were removed to save storage space. Others wondered why only the frames containing predicted trajectories were absent. In at least one case, a user claimed the missing images briefly appeared again hours later, blurry, darkened, and clearly altered, before disappearing once more. A more unusual report came from a technician who worked with adaptive optic systems. According to this technician, the system once detected a distortion pattern identical to those produced when a solid object disrupts atmospheric turbulence, except this distortion occurred far above the atmosphere, in near vacuum conditions. The reading lasted less than a second. It was logged, reviewed, and then silently erased during a database cleanup. Whether this was an error or an intentional deletion is unknown. Some theorists propose that these scattered anomalies, geometric halos, time pulses, brightness spikes, missing frames, might form a pattern. Not necessarily evidence of intelligence, but something more structured than random cosmic debris. Others argue that humans are predisposed to finding patterns where none exist. Still, the fact that these anomalies are consistently downplayed or overwritten raises more questions than answers. Whether these glimpses beyond the lens reveal hidden aspects of the universe or hint at something artificial lurking in deep space remains unresolved. Maybe all of it is coincidence, glitches, errors, or overinterpretations. Or perhaps telescopes occasionally capture things they were never meant to see, moments that vanish quickly, leaving only whispers behind. As with so many mysteries in the sky, what lies behind these anomalies is for the viewer to decide.